Hi everyone, welcome back to my channel. Hobbytech here. Do apologize for long delay. It's been a while that I did not upload the part 6 video of DIY A320 Neo home cockpit. I've been distracted with some other activity or hobbies, or actually I'm tidying up the rooms and the area around the cockpit, and also I've got distracted with other hobby anyway. So we continue with the part 6 of center pedestal. Center pedestal, in my opinion, will be the second hardest parts or cockpit parts that needs to be built after overhead. Overhead have a lot of core switch. Pedestal, on the other hand, have a very unique mechanics that has to be built, which is the throttle itself, the flaps handle, the spoiler handle, the parking brake, and of course the Ecam. So all of those create a bit more complex build, which require combination of construction method, 3D printing, acrylics, and other things. Okay, so it's the combination is creating a lot of challenges, I guess, in creating the center pedestal. So let's go dive into more details about center pedestal. So basically this is the finished center pedestal. Here the monitor is not yet set up, but in this part is almost done. So everything is wired up, connected, and functional. Ecam screen has been properly adjusted. This is mostly almost complete. So I set up the whole things. So here the video show the Ecam. Actually, I bought the Ecam from Java Simulators to shortcut the timing. And here the Ecam is not working. Actually, I have a problem in the Ecam itself, and need to do something about it. So I'm gonna talk about it later on. But yeah, unfortunately, the Ecam from Java Simulator, sometimes it's kind of conflicted and it cannot be recognized, and etc. But anyway, we're going to talk detail further down the line. So this is the finished product of the pedestal and some of the MIP basically. So let's go into a detail by looking at the SketchUp version of the 3D modeling of the center pedestal. Okay, so here we are, the center pedestal design. So I'm going to show you this is the construction made of MDF panels. I think it's 9mm, mostly 9mm and 1.2 or 12 millimeters thickness. I'm using imperials anyway, numbers, so it's 9mm or 12 millimeters thickness on the MDF panel combinations. The structural part, I guess, using 12 millimeters. The panel mostly using 9 millimeters. The whole panel is glued together using super glue. So use the mask and really tight oxygen mask. I guess the filtering mask, because it's the toxic fumes of the super glue when get in touch with particles of the MDF. But when it's glued, it's really super strong and they glued together well. So even I don't use a nail or screw, whatever, in constructing this cabinets actually. So yeah, surprisingly it's very strong. Even with the loading of the throttle mechanism, it can hold quite well. So this is the almost close to the real one, except this is a bit too wide, I guess, in terms of the dimensions, but the whole dimension is probably okay. It's been adjusted from the reference drawing and photos, so it's mostly okay. This is the panels. That the dimension of the panels will be used in the Coreldraw to come up with the right panels, and it will be attached into this construction. So when constructing this using MDF, I try to be very as accurate as possible within millimeters, because once the panel set in, there will be a gaps if not properly done. The gaps probably either too big or too tight. So this one is the structures. There are a brace MDF panel over here for this strut to attach to. This is a double 9mm attached together, so each side has 1mm or almost 1 centimeter or 10mm kind of place to screw the panels from on top. Yeah, so this is the whole construction. Actually, there's this is not here, but actually on the bottom area, this base. So it actually it's screwed into the lower deck of the cockpit. Okay, so the portion here, the upper what do you call it, cover here from MDF is actually covered by fox leather. The fox leather color is kind of blue, dark blue gray, so it's very difficult to find. Finally I found the one that quite matched the original color of the fox leather, so and then cover this MDF panel in with the fox leather, and then screw from inside using a wooden screw, so it won't show up outside on the screw itself. So from inside panels we screw this edges, this cabin, what do you call it, pedestal edges here. Okay, so that is the main constructions. Once I'm done with this dimension, I transfer the dimension into the Coreldraw. So if you see the Coreldraw here, let me find out the Coreldraw. Okay, so this is the Coreldraw. So you can see I show the whole pedestal panel here, including several cutout here for this one is for tiller mechanism. I forgot this one is for what, but I think, oh, for printer. This one is for thermal printer here. So this is the kind of like a bracket to hold the thermal printer. So you have to make yourself, because I might use different brand of printer with a different size. I think it's 80mm white paper, but I think the dimension of the printer is going to be different for every printer that you might use. So this one you might want to create yourself, but this is the acrylic cutout using 3mm acrylic to create a bracket here to hold the printer. This one is for tiller on the side panels on the left side pedestal. This one is for flaps mechanisms. So this is the side panels here, where you put a 3D printed shaft with a center shaft here connected into a potentiometer here. So it's spring loaded, so you have to pull up and then move to this gated channel here. This one is sandwich over here and over here to create a gated kind of mechanics for the flaps. On the other side there's a kind of spoiler mechanism. So this one is not gated but slightly raised, so you can feel it's not smooth as probably the originals. I've been told that it was supposed to be smooth, but I create a kind of gated, so you can feel its tab or its position of this spoilers. But I've heard that actually is not supposed to be like this. Also the switch later on using a push-pull switch, I'm gonna show later on probably the mechanics. It's a car light, an old car lights push-pull switch, which I construct using 3D printed, so I can push and pull the lever when I want to arm or disarm the spoiler. I didn't create simulating the push down to enable the spoiler manual setting. It has to be, the lever has to be pushed down, and then you can then move backward on the handle itself. I don't simulate that because initially I didn't know about it, but once I realized that actually it's supposed to be there, my design has been almost complete, so I kind of I don't want to go back again and design the whole things again. Okay, so yeah, so basically that is the Coreldraw. So this is a 3-layer or 4-layer panel design. So I can start from this is a simple switching panels for the kind of source of the air data from captain or first officer or normal, mostly in the center position. So I connect this into MobiFlight, but since fly-by-wire do not simulate this area, it's not yet activated. This one very important. I use a lot Ecam switches where you can where you can change Ecam display. Here is actually using a hybrid solution. The top panel is actually acrylics. The bottom panel is actually the bottom parts is actually 3D printed to create a kind of housing for this button. So it's a combined housing, so it's not separate switches. I'll show you later on in the SketchUp. This one is opening for the throttle tech. I measured the throttle tech once it's arrived at my home, and I measure the whole thing, and then I try to design and incorporated the opening for the throttle tech throttle. I'm gonna talk about throttle tech throttle later on. This one is for radio panels, mostly acrylics, 4-layer, because there's some race panel here which need to be simulated, and yeah, so this one is 4-layer or acrylics. You can see here there's the button is larger than the opening, so it's a dual stack acrylics. There's a top acrylic and then the bottom acrylic, which actually sit behind this top panel, so it won't pop out, but it will push down to push the micro switch and interact with it. So it mostly temporary switch. Yeah, so this is the whole design. You can compare later on to my picture or drawings on how the end result, but imagine this using this from the Coreldraw. The audio panel, I didn't use it. The SAP is not used because I think it's not, I mean, I don't simulate the audio switching yet, and the fly-by-wire I think is not set, it's not enable these panels to work properly as in actual aircraft. This one is the dimmer panels using potentiometer, which is connected into a real dimmer, so it can dimming the float panel in the main instrument panel in front, and the whole integrated backlight can be adjusted here using the dimmer. So I'm using a powerful high voltage dimmer to control the whole backlit of the whole panel from from MIP or the main instrument panel, pedestal, and other side panel. Except for overhead, that it has its own its own dimmer. Okay, the radar is connected to MobiFlight, but only function several of them, which is the on-off or 1-2 off position of the radar. Auto here, I think this one also working, if I'm mistaken, I forgot. But anyway, because fly-by-wire did not yet have a fully functional radar panels switches working. So this is the engine master switch. I'm not using the throttle tech given from the product itself, so I did scrap it and then just store it. I'm using my own design using a gated switches, so it's really feel like the real one. So it's gated toggle switch. I'll show you later on the switches. And this one is also so this one is using the gated toggle switch. This one is the LED display for the fall, yeah, or fire annunciator. This one is the mode itself, the crank, ignition, start. This is very important switch. So I'm using my own knobs here. This is simple dimmer also. This one is quite difficult because it's you have to arrange the kind of keypad and also big LED here, 7 segment, 4-digit. I plan to use a yellow or green for simulating the real look, but I cannot find the real. I mean, the next size is actually too small, but this one is too big, so I picked the bigger one. So Yeah, this is 4-digit big 7 segment. And the problem with this is not only constructing this panel and the PCB itself, because it has to have certain height. So I'm using micro switch or tactile micro switch from AliExpress with the backlit color. That has a certain height, so you have to measure your own switches first, and then try to redesign the whole thing. So the thickness of the panels, so the round caps here are protruding enough that it's not too far out, but not too recessed that you are difficult in pressing it. So that is the difficulties on constructing it. Also, actually, it's quite difficult to program because ATC panel here required us to really do a certain programming. Fortunately, in MobiFlight library, that's been prepared, but you have to copy that, testing it, and it's quite complex. I made trial and error for several times. Quite takes a few days, I guess, to really understand how it works. And it's quite, I mean, I'm not a programmer myself, but I know logic. I can imagine if people don't have any experience in programming, it's quite challenging to program this anyway. So it's not a ready-made modules or programming modules in MobiFlight that you can use this solutions immediately. So yeah, this one is not only challenging in construction but also programming it. The rest is, I think this one is the rudder trim. Oh, the parking brake, I made myself using resin 3D printer, so it looks like the original. And the mechanics of this parking brake, where is it? I forgot. Yeah, it's actually not here. I'm using the old parking brake mechanics. I forgot where. Anyway, so yeah, I have to create my own constructions. So using a 3D printed filament 3D printed shaft, which is pretty stronger one, and then combined with some metal shaft and several other, so this one is probably difficult. I need to probably address alone just to discuss this parking brake, the flaps, and the spoiler. But unfortunately, it's already installed in the pedestal, so I kind of lazy enough to tear it down again just for the sake of creating a video. I'm sorry about that, but yeah, I wish I can explain it during the creation of this parking brake, spoiler, and flaps, but it is quite complex in my opinion for some of you probably. But the files, the 3D design has been uploaded into my Google Drive, so you can find it there. So you can try to imagine yourself how it works. You can feel free to ask questions later on to me via direct messaging if you want to. This one is not working, just fake parts. This one is working actually. The inside there's a thermal printers, 80mm wide, that can be pushed by this, which I can slew is not slewing, but slewing the paper. So you kind of ejecting the paper, so it's roll out, and then you can tear it out. Yeah, so I can open it also to maintain this or replace the paper, thermal paper. This one is working. This one is just a fake panel, and this one is the cover up panels, just because this is, I'm not this one is for my Ecam, the pilot Ecam side, the pilot side Ecam. This one is blank, so I didn't bought a second Ecam modules actually. So yeah, so this one is the design for the pedestal in the Coreldraw. Everything is here and uploaded in the Google Drive on any layer on each of the panels. So top layer, bottom layer. If I have more layer, I also put names in it, so you can cut it with some millimeters information there, 1mm base button, kind of those things. So it's you can try to understand the cutout, and then if you want to modify, feel free about it. Okay, so that is a Coreldraw. I would like to go showing you this one. This is the Ecam 3D panel. So basically, this is the, what do you call it? the multi-layer panel. So the top layer is acrylic. I think the second layer is still acrylic. The third one is actually 3D printed. So this the switches is sitting here. So if I let's inner box, oh no, button wall. So if I get rid of the button wall, so I created a wall using 3D printed here. If you want to see, this is the button wall. So basically it's a whole there's a hole of for the switches. This one is the, how do you call it, this is the button itself. So it's a dual chamber button, so you can light up one of it. One is for the status that the switch is being pushed or at this position, and the other one is to light up the names of the switch, right? So below it is there's a micro switch attached to this buttons or the knobs, and then also several and then covered with acrylics, which I then engrave the name of it. Okay, so this is the constructions. You go back to the top, you can see the switch with 3 millimeters, 5 millimeters, 4 millimeters consists of 2 millimeters stacked up together, so it's kind of protruding a bit, and it's quite nice. Okay, if you see here, where's the inner or the button wall? So button wall is something like this. So it's basically it's housing the knobs. You see these knobs, yeah. So up and down. So this is quite difficult to create, because if you not accurately creating this button box, it kind of like friction from happening between this button and the housing, and that not feeling that good. So I need to grind it and then to smoothen up this inner parts of this button box housing, and then the button itself basically. So yeah, so this is quite complex. So here also the files has been uploaded. The other ones that I would like to show you is the radio 3D. So this is similarly constructed, but just to not, this is a different one using acrylic only, not 3D printed, but multi-layer. So almost like 1, 2, 3, 4 and 5, actually 5 layer of acrylics. The top one is actually 1 millimeters, but this one is 2 millimeters. The bottom part is 3 millimeters, and also there's some switch stand here to put the PCB of the switch, so it's a bit recessed, so I need to add another 2 millimeters cutout. This one is transparent, the rest is painted. So for the cover, I've sandwiched this transparent cover between two acrylics, 2 millimeters. So basically that's how I created the radio panels. The button itself is cut out by acrylics, and the LED is here connected into the mobile flight, of course, to light up a certain channel or VHF 1, 2, 3, and HF. That will be light up this LCD. This one is for dual stack rotary encoder. So it's a dual gang rotary encoder, so inner and outside, so I can do a big button rotate changing frequency, and so it's a higher frequency or lower frequency changes in radio before you press this one to move from this standby to active. Okay, so that is the radio panels. What else? I think mostly that is the design. I'm going to show you the several parts. This is the switches that I'm using for the master engine switch. So you can see it's a gated one here. There's a gate here, so you have to pull up and then move to the front or to the rear. Forward or rear movement of the switch. I can open this top cover here. I can unscrew this top cover and expose the thread. So the thread you can create using 3D printer, the knobs for the master engine switch, and then thread it to this switch shaft. So then you replace this round knobs here with your special resin printed engine master switch from A320. This is a big size switch, not the micro switch or the smaller switch. So I think I bought it in AliExpress here. It's Sierra 2 Alpha London, or yeah. So that's the code name of the switch. I think it's NKK, the manufacturer. Yeah. So it's the Japanese NKK toggle switch. Yeah. So basically 2-position switch, on. Okay. So it's on actually, not on. Basically no off, because you cannot put in the middle, but either this connected to here. Sorry, I cannot show you. So basically either the center pin connected to this, or to the left side or to the right side, depending on the position. So it's on positions. Okay. So it's good for logic controllers, because you don't have to create something like logic gate or whatever to change the condition. Okay. That is a switch. I told you that I'm using manufactured or pre-made or aftermarket throttle. So I bought a Throttle Tech flight box V2, which is the smaller one. This is the lighter version. The complete version has more functional, like I think a parking brake or something. But this one is only flap, spoiler, and sorry, this one, no, this one, oh, this one is not the one. Sorry, I think I bought the mini box. Yeah, the mini box. Let me now. So I bought this mini box without a parking brake. So only the flap, the flap, the spoiler, and the engine master switch. But then, as I mentioned, I didn't use the provided. I cannot show you. I didn't use the provided master switch or the engine master switch, so I scrapped all these three and only take the center part, which is the mechanic of the throttle itself. And I added myself the trimming handle. There's a round trimming handle, and some of the marking of the trimming itself. That I created using a printed paper, nicely printed in the printing shop, with trying to almost similar color with the whole area. Anyway, that's supposed to be working, so you can like multi-rotating it, but unfortunately it's very clumsy, and mechanics that I've created is a very difficult one to create. I put a lot of gear, big gear, conversion gear, or down down convert gear in terms of ratio. But yeah, I made it like I make it a wrong rotation, so if I move forward, it's supposed to be moving forward, but then the wheel is moving backward. So the sign of it is the marking actually moving backward. The trimmer marking is moving the opposite way. So yeah. So anyway, it's not properly working. The one that I create on the trimming mechanism. But the Throttle Tech main throttle, I think, is quite sturdy. I cannot say furthermore on the detail, because I think there's a message from the Throttle Tech. I'm not supposed to open it and then show to everyone the inside. So there's some NDA, I guess, back from Throttle Tech. So basically I dismantle the whole thing and just take this center mechanic here as my and combine with my own trimming mechanics in the pedestal. The controller also, I using the controller from Throttle Tech. I just rewiring like the master switch. It's actually a very common board, so I cannot tell you furthermore on detail, but it's common board that you can understand how it works, and then you can rewire the whole panels, your own panels actually, from flaps, from spoiler and engine master switch into this Throttle Tech module or electronic, basically to the USB controller. So I'm just reuse whatever Throttle Tech provide inside, as a logic controller. Okay, but the mechanics itself for spoiler, flaps, and the engine master switch has been replaced by my own, except for this. It's actually nicely done. It's clicking, the D10 is quite pronounced, so you can feel very strong D10, and also you can adjust the tension a bit using manual bolt, nuts and bolt. But it's very nice, actually, very sturdy, despite this is almost like a DIY itself, but it's actually aftermarket. Basically, it's been produced by others, but it's DIY quality in my opinion. But it's quite nice, very sturdy, very robust, I guess. But it's not that high quality as branded manufacturer. Okay, so just to manage your expectations. So it's connected into USB 2 port using USB-A type connectors. Okay, so this one is a throttle tech. You can talk to the maker, but I think he didn't allow me to custom requests for the throttle, so I need to bought the whole boxes and I have to just use the center mechanics here, but it's quite okay. Yeah, so I can shortcut. I plan to build it my own. I think I can do it, but I think it just take more time to design, because I need to buy the throttle handle design, 3D design, and then try to create my own mechanics and try to do some trial and error again. Just want to shortcut the whole things and plug in the whole item here into my pedestal. So that's done. The other one that I bought is actually the Ecam. I planned initially to make my own Ecam, but it's just too much and a lot of switches. I need to solder once of it, testing it. It's gonna take a lot of time and effort. I thought I just bought the Java Simulator one. It's quite affordable. Unfortunately, my initial product is not smooth, so it's experienced several like disconnection, like it's not being recognized by the software. So it's kind of annoying, once you're ready to fly and suddenly the Ecam is not working. So it happens several times, and I contacting Java Simulator. I think one of the user told me that actually you have to sometimes send back the unit back to the maker or the manufacturer just to reprogram it. So I said, wow, it's just too much. It's going to take long more time. So because you have to use separate program from Java Simulator with the FCU. Of course, the FCU is quite okay, but here for the MacDo, you have to combine it also to that software. It's different from MobiFlight, so you have to have several software anyway. Unfortunately, with this buggy things, I kind of annoying me. So what happens is I try to redo the whole thing. So using this 3D stuff, or the panel itself from Java Simulators. I think it's a 3D one. So I create my own PCB just to replace the whole control, because controller from Java Simulator is very exclusive. It's not a common and Arduino or something like that. It's actually Arduino based, I assume, because it can be detected by MobiFlight as, if not mistaken, as Arduino. I forgot, but it cannot be programmed by your own. So it's basically using proprietary program from Java Simulator itself. So you have to use their software, and if something happens, upgrading Microsoft Simulator, sometimes it doesn't work. So it's disconnection between the simulator and Java Simulator software. You have to wait for the software upgrade, right? So it happens once actually, and the rest is a problematic one. So this is the module itself. It's quite nice. The display, actually, yeah, I just dismantle this, opening up and tear down the whole thing. I'll show you once I mod it, adding the real Arduino and routed the whole switches manually through cables to the Arduino connected to MobiFlight. So now this boxes has been modified as an Arduino boxes connected into MobiFlight directly without Java Simulator. So that's what I did. Fortunately, I have some experience in designing PCB, so it's not very accurate PCB anyway. I think I can upload you later on, but I discourage you to use it because it's so off that you have to do it manual, whole manual. Yeah, a lot of manual things to do in the PCB because it's my first design, so it's not dimension wise is off. So I don't suggest to use it. So if you want to, I can send it, but yeah, it's just off. You better design your own if you want to, but that's my experience using Java simulators. So yeah, this one is the McDo. So let's go back into slideshow. So I'm gonna show you the several pictures that I'm gonna explain a bit. So this one is the process of construction itself. So this is a frame. You see the brace, several MDF brace. So I'm opening up the bottom panel, so it's just to save materials. But the whole thing is quite accurate, and I think it's a bit too wide, so it's kind of protruding too much to the side. But it's, yeah. So this one is already using the what do you call it? The Fox leather. Yeah. So you can see this. This is the finished one. So it's quite nice. This is the McDo that I'm talking about. This is the radio panel light up. Audio panel not working, but some of the button I use for controlling the simulator. Yeah, so this one is the spoiler one, flap, and this is the master switch. If you can see, well, I can zoom or not. Yeah. So this one is, let's see. So this one is just the mock-up using my old panels. So this is not the real final product. So it's just from my old constructions. Let's see. Yeah. So this is, you can see this is the cabinet itself, bolted into the deck. Yeah. So this one where I put the panels, and then I can screw down the panels into this. Not a rail, it's just a MDF brace structures. Okay, so if you see the finished product, let me show you. This is the finished. The Fox leather has been, yeah, so it's been attached. This one is cockpit door using as just a simple toggle. Parking brake, if you can see, it's already almost close to the actual one. Printer working. Flaps, the spring is outside, supposed to be downside inside here, but the spring is up here. I'm okay with that, but this is actually gated flaps as the real one. This one is a push pull for arm and disarm, but I cannot push down to use the full spoiler adjustment, so it's just push, but I put a gated feel that I can, it's at full or half or what, it's actually can be felt during the movement of the shaft. You can see the engine switch is very nice, and this one actually resin 3D printed, and then this black cover using acrylic, engraved acrylic, attached to the resin cutout. So yeah, very tidy rather than you paint it yourself, so it's going to be very messy. This one is quite okay. This one, as you can see, it is a big 7 segment with yeah, keypad. So it's supposed to be smaller and yellow, I think, or orange, but this one is red. Another one is actually this radio panel. It's working well. It's quite okay. You can see this indicator showing VHF1, VHF2, VHF3. This is the real gem. This is the throttle tag mechanics here in the center, sandwiched with my own trimming, marking, and the trim wheel. Trim wheel is actually very nice. It's actually 3D printed, but I have to put a lot of yeah, it's put a lot of what do you call it? Yeah, so it's to make it smooth. Yeah, so it's a car. What do you call it? It's not a patty, but yeah, it's a putty. Yeah, put a lot of putty, and then sanding it smooth, and then painting it white first, and then create a sticker, a marker. Sorry, a masking sticker with actually with the correct size, and you count it first, and the size of this masking sticker. I create cutting sticker to create this masking tape, and then paint it black, and then clear coat it again. So it's very nice finish, but unfortunately it's not working well. So I can use the trim wheel, okay, but the movement between the trim wheel and the marking is not proper. Okay. What else? Yeah, this is the Ecam. This one is working. As you can see, it's pretty okay. It's working well. This is a temporary switch anyway. So this is a bit off color because this is Java Simulator Ecam, and this is my paint, the blue-gray paint that I made for the whole panel. So it's a bit different or off color. Here I put a yeah, it's just to switch on several function like the software, but this one is added recently just to add my control into the simulator. If I want to adjust the volume, yeah. So anyway, so we're gonna talk about this later on if you want to, but this is probably nothing. So this one is the, let me resize it again. So this one is the, just already shown the construction, just repeat. So you can see the opening for the slider of the chair. I'm going to talk it later on the part 8, I think. This one is to show you the modified Ecam. So if you can see, the initial Ecam from Java Simulator is very shallow in depth in terms of the controller. I put a lot of boxes below just to house the Arduino and some shift register to capture the whole key here using cable actually. So it's quite tedious work to cables all these buttons into the Arduino and the shift registers to read all these switches, but at least it's mine, so I can control it directly from the MobiFlight, you know, as I wish. So now it's working well, integrated to MobiFlight. So I no longer have to depend on Java Simulator's middle software anymore. So I'm just using the case and the buttons, and the rest, the inner components, actually mine, using a micro switch. Yeah. So that is the pedestal, guys. So I hope that giving you a bit of the insight of how I create the pedestals. We're gonna move into part 7 when we talk about left side panels or left side pedestal, which is housing the joystick and also the tiller. It's much simpler, but I'm going to show several parts on that side walls pedestal. Anyway, so see you on part 7. So hopefully you get some insight into the pedestal panels. Okay, see you, bye.